Hi everybody. In this video, we are going to solve the rational equation. This is example 1, part B. And I already gave my whole spiel in part A about you want to pay attention to any restrictions. So in this case, x cannot equal 2. Why? Because our denominator can't equal 0. So if we, while solving this, and we are turning this rational equation into a polynomial, if we get the answer of 2, we're going to throw it away as what we called an extraneous solution. So let's get started. The way we will be solving this is we're going to clear out our fractions by multiplying both sides completely through by the LCD. This is over 1. The other two fractions there have x minus 2 in the denominator. Those are the ones that make it a rational equation. And my lowest common denominator will be x minus 2, just like that. That's what I could make my denominator if I wanted everything to have a common denominator. Now, by doing this, we skip the step of actually finding the common denominator. If you are finding a common denominator, you're doing too much. So when I multiply that right there, okay, everyone saw. So this is going to go right there. When it does, x minus 2's will cross out because you'll have x minus 2 over x minus 2, and the only thing left will be x equals. Next. Now we'll do the same idea. We're going to distribute it over here. Again, x minus 2 will cross out. We will be left with the 2 that's in the numerator plus 2 is there. It's not crossing out. But when this distributes here, the x minus 2 is going to get multiplied by that right there because it has nowhere to go. It's not going to get crossed out. Now, some of you maybe brought over 2 over x minus 2. That would have given you x minus 2 over x minus 2. And essentially that would give you 1 equals 2. No solution. Boom. But I'm just showing you this method because not everything works out as smoothly as that, right? So here, the math is going to work out as x equals 2. Now pay attention because careless errors with positive and negative signs are really destroying you, okay? It's throwing off your whole entire problem. So just you got to be careful. I mean, I make mistakes too. We're all human, but we all just need to be careful. And um, sometimes I make mistakes and it makes it into a video, I'm sure, okay? I'm not perfect. But a lot of the times I will catch my own mistake and I leave it. I don't even edit it out or anything. I just show you guys like something will happen in the work and I'm like, wait, that doesn't make sense. And I'll know there was a mistake because of it. I'm sure you've seen that happen in videos before, right? Anyhow, so let's get everything with an X. So like this right over here, let's move that all to one side. And then these over here, we can combine and keep on this side, right? So let's go. We will subtract 2x. So x minus 2x, we have negative x on the left. 2 minus 4 is negative 2. Divide both sides by negative, and I get x equals 2. Now, if we were such silly geese and not paying attention, we might be like, okay, great. However, if we pay attention, you will see that x can't equal 2 because we saw before that that was our one and only restriction, right? X can't equal 2. If I go to plug it back in, I'm going to get a 0 on bottom, a 0 on bottom. I'm going to have all sorts of problems in the problem, right? So it'll be undefined. And I don't want any of that nonsense going on, right? Don't mind the other problem from before. Um, Let's just zoom it out for you. There we go. Okay. So there you have it. Okay. So basically we got an answer, but we checked our restriction at the very beginning. That would make the original, we're solving the original problem. Even though that rational turned into a polynomial, that's what we are solving. We stay true to our roots, right? So if that is the original problem, we need to honor that. So in this case, what is the answer? The answer would be the empty set. Oops, can't see. Ay, ay, ay. See, I gotta like think a little bit more about how I um, make room on some of these problems because it doesn't fit to the video nicely. So the answer is either that, or you can say something like no solution, right? That means the empty set, right? So any version of that, right? So no solution in this example. Make sure you're checking for your extraneous solution. And again, the spelling of extraneous, there you go. Extraneous. All right. Example 2 will be coming up next. If the playlist thumbnail is easiest for you, you could go there. Or if the description box with the list in order broken down by section and example, if that's easier, you could check that. Hope you followed along. And if you have example 2 in front of you already, or you see it in the thumbnail, maybe pause, do it first, and then hit play and see if you knew everything I mentioned. If you wanted to go faster, play it in double speed. Knowing that you got the right answer isn't just enough, because I am dropping gems for you of things that will be relevant. I taught calculus for many years, so, you know, trust me. Okay, let me help you. That's it for now. Adios.